conditions. F is continuous on the closed interval, and F is differentiable on the open interval. That is there in your paper. The more you write the theorem, the more you remember it in all its details. So by MBT, there is a C in 1 to 3 where F prime at C equals the average rate of change. Instantaneous rate of change equal average rate of change, yes? What's the instantaneous rate of change at C? 3c squared plus 1 equals, what was the average rate of change or the secant slope? 5, 27, 30 minus 2 over 2. So 3c squared plus 1 equals 14. So 3c squared equals 13. So C is, normally I'd say plus or minus the square root of 13/3, but it has to be in the interval. So C is square root of 13/3. That's the place where the tangent slope equals the secant slope. You with me? Are this going well? Cool. Okay. Would you then, let's consider volumes. Yay. All right. This is a pretty cool lesson, I gotta say. This is great. Love it. Before this, you had hard, fast rules. I said, if it's around X, use X. And if it's around Y, use Y. Right? Right. Now, those are at the those hard, fast rules are now slow, soft rules. Something that's not so much, okay? Instead, you need to be very clear on slices and what gets made. So check this out. First, before I go anywhere, I need you to remember that if X is the variable, a slice looks like this. And when I say a slice, I just mean a rectangle, yeah? Areas and volumes are all about rectangles, and rectangles revolve. Y slices go this way, yay? Because they're dy high, and this is dx thick. So delta x thick. Okay, cool. Now then, consider that as we go on to this example, all right? You're going to find a method for finding volume another way out of necessity. So consider this graph here. What do you know about that graph? It is overall the shape of a x cubed, positive x cubed with zeros at 0 and 2. And it just passes through 0 but bumps 2, yeah? All right, so can we all agree on the graph? Excellent. All right, now, if this is revolved around the y-axis, we would use y, yeah? That's what you've been taught, not me. So, okay, why not? Well, if it's around the y-axis and we're going to use y, then don't we need to put the equation in y terms, yeah? So solve for x. All right, well, cool. Y equals x times x minus 2 squared. Solve for x. Go. Exactly. You're right. You're right to say not happening, okay? So the idea of isolating x in a cube is not going to happen. This would actually have to be 1, 2, 3 different equations if you wrote this in terms of x. It's terrible, gross, and in many cases, not this one, but in many cases, it's not even doable. Right? So this is not happening. Instead, so the point is, y is not happening. Can we use x? All right? Now, or is that breaking down? Well, let's consider if we use x. What would the slice look like if we use x? X right there. Okay, so this kind of slice, yeah? All right. Now, if that slice is revolved about the y-axis, then it would look something like that, yeah? Now, students the first time want to say, oh, so it's a washer. Well, no, it's not so much a washer. It's really thin, okay? And it's really more like this, yeah? That's how thin it is. It's like that, yeah? Well, how do we? All right, so we're going to get a lot of those. We're going to get a slice there and revolve it, and we'll get another slice there and revolve it, and it'll be a really thin, empty cylinder almost. And we could keep going until we get lots of these, all nested within themselves. Almost as if you had a whole ream of paper and curved around. Well, how could you find the volume of that? What is the volume of these, we'll call them cylindrical shells? What do you think? I'll try it again. Okay, so this, it's got such, it's tempting to say pi r squared minus pi r squared, yeah? And that makes sense, but the real way you want to go is this. How do you find the volume? Area of the base times height. Now what's the height? dx or dy? dx. Yeah, the thickness of this is really thin x. Okay, so it's dx. Now, if you then unwrap it, that's the key to getting started. If we unwrap it, it's just barely paper thin, and actually thinner than a paper. And that thickness there, that thickness is more like dx, right? Now the area of the base, I think length times width times height, I guess, if you want, where we now, one of the dimensions is dx. What is this dimension? This guy comes from what in the cylinder? 2 pi r, yeah, it comes from the circumference. This distance was what this was before unwrapping. So this is the circumference. 2 pi r. True. What about the r? Is it constant or changing? Okay. So when I have my slice here at 1, what's r? 1. And when I have my slice here, this green one, let's say it's at 1.5, what's r? And I have to say I just drew a vague slice here at x. What's r? So it seems like r is x, whatever the x is at the slice, yeah? What about the height? The height is constant or changing? Changing. It seems like it's changing vertically. So what should we call it? How do you find the height? It's y, which will have to be an x term, so the height is the function, yeah? Now we knew that had to come into play sometime, and it does, but not in both places, all right? So if I then took that and added all of these little paper-thin cylindrical shells to get like a stack of paper and rotate it around, then we would get an infinite sum of many length, width, height rectangles where the width is 2 pi x. The height is, I guess it all depends on how you look at it, f of x, and the thickness, whatever you want to, again, how you call each dimension, is dx, yeah? Bounds, where are they? 0 to 2. So when you do these, it's not the revolved bounds, it's just the original regions bounds. It's 0 to 2, right? Not negative 2 to 2, right? Yes, you're supposed to say yes there. It's 0 to 2. All right, try that in your calculator then. 2 pi we typically put out front, x, and the function. We use our calculators today to evaluate these. The setup is the part I want to focus on. Although this isn't terribly hard to integrate, I gotta say. Okay. So, one of the most common errors is forgetting the 2 pi's, so always put it first. Okay. Plus 0 to 2 of, what is it, something like x squared x minus 2 squared. Yep. Why? Monica, you messed me up. Just kind of. Thank you for letting me know. That would have confounded me, I'm sure. 6.70206. All right, cool. 6.70, what was it again? 2? Yeah. 206. Okay, cool. Now then, that is actually awesome because now you have ways of doing problems that wouldn't have been doable normally. If I tried to use washers or discs here, it would have been a nightmare, just a nightmare. And in many cases, not even possible. So this will make situations where you can do problems that weren't doable before. It also means you're going to have choices, and you're going to have to be on your game in terms of making that choice. We'll get to that in a minute, but first, let's understand the big idea. When the slices you want to revolve are parallel to the axis of revolution, a cylindrical shell is formed. So, for example, if I had a slice like this and revolved it around the y-axis, then I get a cylindrical shell. Likewise, if I had a slice like this and revolved it around the x-axis, then I get a hollow shell. You with me? The volume of the cylindrical shell is an unwrapped rectangular prism of infinitely small thickness. Now that thickness is dx or dy. The unwrapped edge that comes from the circumference, that is 2 pi r, and that radius could be x or y. And the height relates to the curves, and that is the function. And again, it might be in x terms or y terms, depending on the case. Right? That's the big idea, though. Think of unwrapped rectangle, and the dimensions are circumference times height times thickness. Now then, let's consider another one. Find volume using, there's different types of questions. So sometimes they'll say exactly what to do, and then sometimes they'll give you a little less guidance. So in this case, they say the region enclosed by y equals sine of x on the x-axis on 0 to pi is revolved about the y-axis. So here's sine of x on 0 to pi revolved around the y-axis. So the revolution looks like that, yeah? And the top would also have a kind of empty hole, butt cake kind of thing, yeah? Should make a little butt cake kind of activity, am I right? Use x as the variable of integration and cylindrical shells to find the volume of the solid. Now, if I'm supposed to use shells and x, then let's draw an x slice. And hopefully verified that it is a shell case. Isn't an X slice like this? All right. And if I revolve such a slice, is that a washer or an empty shell? It is an empty shell. It's an empty cylindrical shell. Okay, a very thin, onion skinny kind of shell. All right, cool. Now that said, see if you can tell me what the volume is. Set it up and calculate it. You may use your calculator to set it up. Computer calculators and radians, juniors, or AP Physics people. Oh, we could do this by a little integration by parts, shall we? Right? I don't like to demonstrate the skills I worked so hard to find. All right. So, ready? Answer, go. Boom, love it. What's your integral outside or inside? From, all right, what are your bounds actually? 0 to pi, cool. And your integrand? And what does x represent? The radius. And what does sine of x represent? The height of the shell. You see in rough rectangles. All right. And it is indeed 19 point, I forgot, 19.739. Again, don't worry about units, cubic units, you can leave them off. So far, so good? All right, let's work through a little less guidance. Sometimes they'll ask you to use shells, and they'll tell you, I want you to use shells, not discs or washers. But they won't tell you what variable, and so you'll have to figure it out. So would you give me a quick sketch of yield region? The x-axis, so actually it's like this kind of region. We loved about the x-axis. All right, cool. Now then, the question is, use shells. So I'm supposed to use shells, and before I set up the shells, I need to figure out what does the slice look like. Shells, so the question goes something like, shells, do I get a shell when I revolve this or this? Well, a slice like that, revolve. Will that be a shell? It will. Okay. Now, say you had done this. If I did a slice like that, would that be a shell? No, that's what? A disc, okay? So, would I get the right answer if I, what kind of variable is that slice, or that kind of slice, right? Is that X or Y? Okay, so I could find the volume two ways, depending on what, if the question asks. I could use that, X, discs, and how many integrals? Two. Why two integrals if I use that? I had to go to different points, okay? I could use X, discs, two integrals, if they didn't care how I did it. And I would get the same as if I used Y, and we said Y is going this way. And that results in a shell, and would that be one or two integrals? That's one integral. Now these should be the same answer, and so if you had freedom to go either way, it's nice to have a check against each other. But we're going to go the shell's way because they asked us to. So here's a little different now. This is going to, if I were to cut, rather than unwrapping side to side, we're going to unwrap up and down, so it's going to be this deal, yeah? All right, but it's still 2 pi times the radius times the height times the thickness. 2 pi out front. Talk to me about the radius. Isn't the radius the distance in the, go to the circle and look at the distance in the center of the circle to the outside? That's the y distance, right? So 2 pi y. The height is actually this distance. I know it feels like height should go up and down, but we should get well past that. Height of a cylinder is the distance between the two bases. The bases are circles, so when I say height, I mean the distance between the circles. Follow? All right, so what is that height? Yeah, everywhere you look at these slices, the right edge is the line, the left edge is the square root. And if I want to get a positive volume, I need to make this positive dimension. So the right is the line, and the left is the square root, yeah? But I'll have to put them in y terms because the thickness of this slice is dy, yeah? All right, so here we go. What is the line in y terms? 2 minus y. And what is the curve in y terms? Y squared. Last but not least, the bounds. How do I find the bounds? One of the bounds is pretty obvious. What's one of the bounds? 0, because the low edge is 0. Are we looking left to right or low to high? Low to high, because it's y, it's low to high. So I need the intersection point, yeah? What is root x times, I understand we're looking for y values, but let's start with x values and then we'll find the y. How would you solve that? That's not very much fun. But oh well. Got it, go! I guess you could do guess and check. Does it solve by guess and check? I hope this is clean. Is it clean? 1 and that's all? It would be 2x points. So y equals 1. Does that make sense? Yeah. Okay, cool. Guess and check. Don't poo-poo guess and check. Guess and check, sometimes it works and it's great. All right, are we cool on the setup? Yes, Mr. Rickman, I'm great. Throw it in the calculator, people. Gotta say, the energy's a little low again. It's not Monday this time. What's the deal? Because it's cloudy? I thought we were gonna run, well, maybe we should run the mile. Is that the deal? Passion for math today or running the mile? All right. Uh-oh. Oh, it's no problem. Oh. Did you get 2.6179? No? Okay. Okay. Should we do it with this to check, or now let's move on? Okay. Okay. Sometimes rather than say use shells, they'll say use this variable, and you'll need to know, oh, based on that variable and what it looks like when you revolve it, I'll use this method. All right. So you kind of go where the question takes you. There's a lot of different kind of combinations of figures and questions, so you need to get used to them all. I'm trying to give you a good sampling of possible questions. All right, so would you graph a sketch or sketch a graph there? x-axis to y-axis, and x equal 2. So that region revolved about the y-axis. All right. Use x as the variable of integration. So your choice isn't, there's not a choice at all, actually. You're not going to choose between discs and washers. They're kind of making the choice for you the minute they tell you x. So please, I beg you, draw a slice. Don't try and do this analytically. Just look at the picture and what the slice gives you. I can't tell you how important it is to just draw the slice. That's what tells you what to do. If you slice in x, then the rectangle goes that way. And you revolve it around the y-axis, then what is made? A shell. That's an empty cylindrical shell. All right? So, volume is 2 pi. What is next? Here's the slice unwrapped. Okay, the thickness, what is it? dx. What is this dimension? 2 pi, the radius is x. And what is this dimension? That is how high we're going up to get to the function. We find the volume. This also we could do by integration by parts if we wanted to. You can see how useful integration by parts is. You often have to use it when you do a shells problem. Did you use 0 to 2 for your balance? What's your integrand? X e to the x. And something like 52.709 or 70710, something like that. Yeah? All right. Cool. A little more freedom now. It's not, when you read this question, sometimes they just say, find the volume. I don't care how you do it, just find the volume. So, the region enclosed by the square root graph, the x and y axis, and y equals 4 is revolved around the x-axis. Find the volume twice, once using x, once using y. Try that, and we'll go over it in a minute together. Let's actually make sure you have the region correctly graphed. What is the shift on the square root graph we got there? Right 2. So that guy, x and y axis, and y equal 4. Oh man, darn it. All right, so we're looking at this here region. Follow me? Around what axis? X-axis. All right. Now, these answers should agree, because it is the same volume, whether you use x or y, it's the same region revolved around the same axis. You should get the same volume. So try that, work together with your math amigos, or prefer.
point of this is largely it's good to have choices because one is definitely easier than the other, I think. This is a humdinger. Question is, can you get two agreeing answers? Oops. All right. All right. Almost ready. I'm almost ready. All right. So, question is, did you have two shots of this? Did you get it right at least once? Well, pick your answer you feel most confident about and shout it out. Are you ready? Well done. 502, yes. Okay, so now the question is, were you able to find it both ways? Which way did you find it successful? Yeah, that was the shell's way, right? Make it a lot easier. In this case. So Let's first verify your shells, although it sounds right. Do you agree that your slices go this way, and you're talking 2 pi, 0 to 4 of, what's the radius? Y, and what's the right minus left for the height, or the distance between the bases? It's the curve, oops, it's the curve in Y terms, so Y squared, I heard, plus 2, yeah? And that is indeed correct. 502 point, what are the 3 decimals? 655. Okay, cool. Now the question is, how the heck do we get the x to verify? Now, let's draw some slices. If it's x, it's this way, yeah? All right, these x's, when I revolve them, what do I get? What kind of figure is that? That's a disk. What kind of, how about over here? Washers. So you should have 2 integrals, disks and washers. The first one is pi. What's r in the first region? What is the r for the disks? Varying or always constant? Always constant. The radius for all those is 4. And those go from where to where? 0 to 2 is when the curve starts to take effect. After that, we hand off into a washer situation, still dx thick. Big R is the distance from the center of the circle out to the outside edge. Is it always the same or varying? Always the same. Big R is always 4. Little r, that's the distance from the center of the circle to the inner circle. That seems like it's changing, and that is the distance to the x minus 2 curve, yeah? Yeah? And then the bounds. 2 is where it starts. That's easy enough. Where does it end? How'd you get that? Yes and check works. I actually thought about it's just easy. You know that y has to be 4, which means the inside has to be 16, so x has to be 8, yeah? All right, so that, if you throw it in correctly, is indeed 502. But the point is, it's nice to have choices because one's a heck of a lot easier than the other. Are you down? Okay. So when you have choices, just so we're clear, when you have choices, you don't choose, I'm going to use shells, I'm going to use what? That's not the choice. You don't say, hey, I'm going to use this method because I love shells. You say, what variable do I want to use? And that's what makes the choice for you here. Back here, I wasn't going to set out to use shells because it's shells lesson. Shells happen because y is better. X is 2 integrals, y is 1. Y is better. And that's why then a slice of y resulted in shells. But again, it's not a choice of shells versus washers. It's what variable do you use? That's the choice. All right? When you make that choice, you think, well, which one's easier? Is it 1 integral or 2? Which one's easier to integrate? Arc sine versus sine, for example, I would want to use sine. So those are some of the things that go through your head. Try this last one, please. It's up to you, however you do it, but do it well. I know it's a little iffy on parabolas. I suggest you say, what's the 0? Because that's where the vertex is. The vertex is where the 0 happens. The square 0. picture not very good, is it? Oops. Doesn't make any sense. What did I do wrong? I grabbed this one. Did I find this intersection here? Oh, I guess my picture's just that bad. Okay. All right. How we doing? Hang on just a second. I'm not clicking it. My bad. Boom. All right. Ready to say your answer? In a judgment-free zone, right? Answer is 37.6. I said 37.699. You got 42 also?
Yeah.
Over here? You got 42? All right. So let's start here. Did you use X or Y? Okay. X is terrible for a lot of reasons. One is the parabola would have to be two equations. Another is you'd have two integrals and washer. It's a mess. All right. So we're going to use Y because it's always the same parabola in Y, and one integral versus two. All right. So cool. We're going to go Y. When I go Y, shells or washers? Shells. Cool. What's the radius? Y. What is the height or the distance between the circular bases? 4 minus Y minus Y minus 2. Oh, I didn't square that. That's why. Oh, no, I did. I don't know. Oh, nope. I put my parentheses in the wrong place. I only have Y times. There's so parentheses. I should know better. Shame, shame. 42.4115? Guys are good. Your intersection points were in Y, what? 0, 3. And so you got 42 point something. What was it again? 411? 412. All right. Excellent. I'm very impressed. You guys are good. I would say better than me, but that's not true. Yeah. Someday. Okay. Last but not least, you need to understand something, okay? When you did discs, A is pi. Usually the radius is the function, yeah? And it's squared, and it's dx or dy. Now, you could be a total knucklehead and still get the right answer. For example, if you had a region here and revolved it around the y-axis, despite the fact y is negative, because it's squared, it wouldn't bite you. You would still get a positive. Oh, time goes so fast. We'll get caught up tomorrow. Maybe I should push that thing back to Friday. How many sets do you have? Now 3? Maybe we could turn in 85 extra factors. What do you think?
We got through like one question. It's dropped.
And yet I don't see anybody in 7th hour for help. Huh. Interesting. Okay, I guess we'll do everything tomorrow.